Okay, what you're seeing here is Victor with our current prototype. This is basically everything that will be on the plane. That's over here in this module. We have our GPS, we have our video downlink, we have our data downlink, and we've marked the target out over here in front of our engineering building, and we're moving across the above the second floor roof on the engineering building, and trying to track a target. This is basically our first effort at 3D control. We started with 2D control and just stayed on ground level. And now we've implemented, as we go along, we keep coming up with a new working prototype and find issues that we need to handle. Over here is what we'll see from the plane is the heads-up display where eventually this is going to be the attitude of the plane here across the horizon. We have vital information, our ham call signs. A couple of us went and got ham license, like Victor mentioned, because we're transmitting in the amateur bands and above 1 watt. Once again, our GPS information is basically all we're using to track here. GPS has pretty good lat and long resolution. The altitude is horrible for our application. It drifts sometimes 10 meters, we notice. So in the sensor package that was mentioned earlier, we will refine our altitude. You notice our target is over here, and we're kind of tracking up low and high, but always kind of staying left and right of it. So this is the altitude here, and proof of concept to prove to ourselves that we're moving in the right direction. We have a protocol set up from the plane to the base station. We've a lot of networking ideas that go on here. Basically, we set up a protocol with a header and then the data information after it. And this is what it looks like in ASCII here going across the line. We have our current location of the plane, how many satellites we're using to track this module. We're doing about up to 12 satellites, and it helps us let us know what our resolution of GPS is. This is a differential. It locks in on a close target with the airport near our school. We have information. This is how we target. We can click wherever the plane's at. We can click it, grab that GPS spot, and then we have a known GPS location. We enter a target, we upload it to the plane, and hit auto track, and our gimbal will start doing the algorithm that you saw earlier in the video before. That's mainly where our design is at right now. We're continually updating this and designing it. It's in C#. We have a number of people who have experience in C#. The PIC 32 is where we have C code in there, and that's handling all the protocols for our data links. We have a number of UARTs that we're controlling. Protocols like SPI and I2C are involved in this project. So it's very, we're doing things on low-level programming and high-level programming, a wide array. So we have a number of people involved in this project. We have mechanical engineers and electrical engineers have come together. The mechanicals are doing a number of analysis on the plane, like vibrations and different kinds of flow over the aircraft and the wind tunnel. And our gimbal is going to stick out of the bottom, so they're doing some analysis on things like that. We have the feature plans also, in conclusion, the feature plans obviously mentioned earlier was phase 2, so we're going to keep moving forward on autonomous airflight. We've had a representative from Edwards Air Force Base come out and visit with us recently, and we gave him a demonstration, and he gave us some new ideas, things like fuel in the wings and different systems that real planes have, and more issues that a big aircraft and or fighter jets would do. So I'd like to thank you for letting us speak today. Really enjoyed it, and thank you.